1.4 talks about complex numbers. And in this lesson, we're going to add and subtract complex numbers, we're going to multiply and divide complex numbers, and we're going to perform operations with square roots of negative numbers. So the imaginary unit I is defined as I is equal to the square root of negative 1, which means that I squared is equal to negative 1. The set of all numbers are in the form of a plus bi, with real numbers a and b, and I, the imaginary unit, is called the set of complex numbers. The standard form of a complex number is a plus bi. So your big thing here is you've got to know that I is equal to the square root of negative 1. This allows us to now take the square root of a negative number, because when we take the square root of that negative, that's like a negative 1, and therefore we just put an I in our answer, which we'll talk about towards the end. Now if I took that I is equal to the square root of negative 1, and I square both of these, because remember what you do to one side as long as you do to the other is equal, then we would get I squared equals, and over here the square and the square root would cancel, so we would get negative 1. So we also need to know that I squared is equal to negative 1. And then the other really important thing here is that standard form, we always put the I last. So think about it like in English. You know, you were taught that if you say you're going to the store with your friend, you would say Johnny and I are going to the store, not I and Johnny. So I comes last, just like it does in English. Excuse me. So operations on complex numbers. It says the form of a complex number a plus bi is like the binomial a plus bx. To add, subtract, and multiply complex numbers, we use the same methods that we use for binomials. So when we add and subtract with complex numbers, we just combine our like terms. We combine everything that doesn't have an I together, and we combine everything that does have an I together. When we multiply, we treat I just like x as well. Okay, so like if we had x times x, we would say that's x squared. So now if we have I times I, we say that is I squared. But then we have to do something else with that because we know what I squared is equal to. And we'll talk about that when we get there. All right, so example 1 says perform the indicated operations, writing the result in standard form. Remember, standard form has I at the end. All right, so on A, the first thing I'm going to do is get rid of these parentheses. So remember, if the parentheses at the beginning, there's like a 1 there. So you can just distribute that 1. And then whatever sign is here, that's like a positive. If there's no number, then that's like a positive 1, and we're going to distribute it so we can get rid of these parentheses. All right. So then we're going to combine our like terms, and I'm going to group them here for us. So because we want standard form, which remember is a plus bi, we want our i's to be at the end, let's do everything that doesn't have an I first. So I have a 5, and I have a plus 3. And then I have a negative 2i, and I have a plus 3i. So 5 plus 3 is 8. Negative 2i plus 3i is a positive 1i, or we could just say I. And so we get 8 plus I. They're not like terms, and I is at the end, so we're finished with that one. We go to do the B over here. Remember, there's a 1 in front of that parenthesis, so we're going to distribute it. And then this one has a minus, so that's like a negative 1 there, so we're going to distribute that. So that would give us a negative 12, and then be careful, that's a negative 1 times a negative I, which makes it a positive 1i, or just positive I. Then I'm going to combine my like terms. I'm going to use my non-i's first, so I have 2 minus 12. And then my i's, I have a 6i, and I have a plus I. 2 minus 12. It's negative 10. 6i plus I is a positive 7i. And so there is our solution. Those are not like terms, and I is at the end. Example 2, we're going to find the product. Well, even if we don't know what the word product means, look at the problems, guys. It's a number beside a parentheses. That means to multiply. So in this first one, we're just going to take the 7i and we're going to distribute it. So 7i times 2. And then 7i times negative 9i. Well, break it apart if you need to. I'm going to just write that real quick here. Remember, first thing is a positive times a negative is a negative. Then do your numbers. 7 times 9 is 63. Then do your i's. I times I is I squared. Now, a couple things going on here. First thing is I don't have I at the end. I have an I at the beginning and I have an I squared at the end. But also, we had learned back on one of the previous slides what I squared was equal to. So I'm just going to copy down what I've got here. So I've got 14I minus 63. Now that's 63 times I squared, okay, because they're side by side. So I'm going to put times, or better yet, I'm just going to use a parenthesis for my multiplication. What is I squared equal to? Well, if you look back on one of the previous slides, we said I squared equaled -1. So now I can work out this part. So I'm going to bring down my 14I, and I have a negative 63 times a -1. That's a positive 63. Well, they're not like terms, so I can't combine them, but I don't have I at the end. So I'm going to look at what I've got here. I've got a positive 14I and a positive 63. So I'm just going to switch them around. I'm going to bring the positive 63 in the front, and then I have that positive 14I I'm going to put after it. Now it's in standard form, so there is our solution. Now on B, we're multiplying two binomials. And this is no different, guys, than if I'd have said 5 plus 4x times 6 minus 7x. Hopefully you'll recognize that either that is FOIL, distributing, or you can use your box. And so I'm going to do the box using what they gave us. So it's 2 terms by 2 terms. So I need a 2 by 2 box. Sorry, I'm working on it here. All right. So a 2 by 2 box. I'm going to put 5 plus 4i on one of them, and the 6 minus 7i on the other side. And then remember, when we multiply the two things outside the box that we're going to fill in. So starting at the top left and going across, I got 6 times 5 is 30. 6 times positive 4i is 24i. Negative 7i times 5 is negative 35i. And negative 7i times positive 4i. Well, if you need to, write it down so you can see it closer together. Or just take it piece by piece. What's a negative times a positive? A negative. What's 7 times 4? 28. What's I times I? I squared. Okay, I'm going to write down what I've got here. Now remember, the nice thing about the box is the diagonal usually has my like terms in it. And it does in this case. So I have 30. 24i minus 35i is negative 11i. And then I have my minus 28i squared. Well, again, there's that I squared. So we're going to work on it. So let's bring everything else down. So 30 minus 11i minus 28 times, remember I squared is negative 1. So now I can multiply those two. So 30 minus 11i, negative 28 times negative 1 is positive 28. And now we've got like terms here. So I'm going to combine them. So 30 plus 28 is 58 minus 11i. It's in standard form. I is at the end. They're not like terms, so there is our solution. The conjugate of a complex number. It says for the complex number a plus bi, we define its complex conjugate to be a minus bi. So a conjugate just means the sign in the middle is going to change. The sign in front of the different piece, okay? So what we probably don't like so much. In this case, it's something with an I because it's new. Sometimes you'll see them with square roots because we don't like square roots. So notice the A stays the same. The BI is the same. It's only the sign in between them that's going to change. All right? And then it says a product of a complex number and its conjugate is a real number. So if I took A plus BI and I multiply it times its conjugate, you can go through here and see they did FOIL, which we would use a box, whatever. They ended up with an I squared, so they changed it to negative 1. But when they get done here, they end up with two things that don't have an I in it that they're going to add together. So we're going to use conjugates to help us get rid of an I when we don't want an I in our problem. And we use this with division because complex number division, it says the goal of a complex number division is to obtain a real number in the denominator. All right, so what that's saying is we can't have I in our denominator. We can't have I on the bottom of our fraction. So we will multiply the numerator and the denominator of a complex number quotient by the conjugate of the denominator to obtain a real number. So because we can't have I in the denominator, we're going to multiply it by its conjugate. And what you do to the bottom of the fraction, you have to do to the top of the fraction to keep it equal. So we're going to multiply both the top and the bottom, the numerator and the denominator, by the conjugate of the denominator. And so this says divide and express a result in standard form. So we notice we have I on the bottom of a fraction, and we can't have that. So that means we're going to multiply it by its conjugate, which means the 4 and the I are going to stay the same. It's only the sign in the middle that's going to change. And what you do to the bottom of the fraction, you have to do to the top of the fraction. So guys, this should be the same thing on top and bottom. Now, we're going to multiply. So on top, we got 5 plus 4i times 4 plus I. And on bottom, we got 4 minus I times 4 plus I. So we're going to get to do FOIL on the numerator and the denominator here. Or we're going to use our boxes. So I'm going to do a box for the numerator first. It's a 2 by 2. So I have 5 plus 4i, and I have 4 plus I. So when I go through and do this, 5 times 4 is 20. Going across, 4 times 4i is 16i. Bottom left, I times 5 is 5i. And then I times 4i is 4i squared. So I get 20. I'm going to combine these two. 16i plus 5i is 21i. And then I have a positive 4i squared. I know I need to work on that I squared. So 20 plus 21i plus 4 times I squared is negative 1. So 20 plus 21i, 4 times negative 1 is negative 4. And then I'm going to combine my like terms, so I get 16 plus 21i. So on top here, I have 16 plus 21i over. Then we're going to do the same thing for our denominator. So it's a 2 by 2. I have 4 minus I on one side and 4 plus I on the other side. Multiply. 4 times 4 is 16. 4 times negative I is negative 4i. I times 4 is 4i. And I times negative I is a negative I squared. So I have 16. Combine my like terms here in the middle. 4i minus 4i cancel. And then I have my minus I squared. I know I can deal with I squared, so I'm going to bring down my 16 minus, and I squared is a negative 1. Then I have 16 minus a negative. Well, minus a negative is a plus, so 16 plus 1 is 17. And so we get 17 in our denominator. Now, the only other thing we could possibly do here, guys, is if all three of these terms were divisible by some number, we would divide all three of those numbers by it, okay? But 16, 21, and 17 are not divisible by anything other than 1. So therefore, this is our solution. Notice our I is gone on bottom, okay? Because in that second box that we did, we were multiplying conjugates. If you end up with an I there, then there's a mistake somewhere. So be careful of that. All right, and then the principal square root of a negative number. It says for any positive real number b, the principal square root of the negative number negative b is defined by the square root of negative b is equal to I square root of b. All right, well, we had learned before that if we have like the square root of negative b, we can separate that. That's the same thing as saying the square root of negative 1 times b, correct? And then we can separate that by saying that's the square root of negative 1 times the square root of b. We know the square root of negative 1 is I. Whoops, that's supposed to be a b. And so then we would just keep our square root of b. So that's how they got that. I don't walk through every step like that. If we end up with something like the square root of negative b, I would ask you, okay, what is the square root of the negative piece of it? When I take it out, hopefully you will tell me, well, the square root of a negative 1 then would be I, and we still have b underneath here. Now, if b is factorable, we would need to factor it and see, could we end up taking the square root of it? If it's not, then we don't. All right, so here we have, it says perform the indicated operation and write the result in standard form. So we've got the square root of negative 27 plus the square root of negative 48. Guys, before you can do anything with the square root of that involves a negative number, you have to deal with that negative part first before you do anything else, okay? So here, the first thing I'm going to do is I'm going to deal with the square root of negative 27. So I know I can take the square root of that negative because that's I, and it's going to leave me with a 27 under there. Plus, and I'm going to take the square root of that as well. That gives me I, and I'm going to put the square root of 48 under there. Now, I know it's been a while because it's before the break, but remember, you can only add and subtract radicals if they are exactly the same. They both have to have the square root of 2, or they both have to have the square root of 5, and then we only combine the coefficients in front of it. Well, in this one, I have the square root of 27 and the square root of 48. I can't combine them, but I might be able to break them down. So let's try that. So what I'm going to do is I'm going to bring this I down. Remember, anything that's on the outside will get multiplied by anything that we take out, okay? So I'm going to have I times, and let's break down 27. So 27 is 9 times 3, and remember we go to our prime numbers. 9 is 3 times 3, and we bring down this 3. Since we're looking for square root, that means we're looking for 2 of a kind. Well, I have a group of 3's there, so I'm going to take one of them out. And this 3 that's by itself stays underneath that radical. All right, I'm going to go ahead and just bring down my plus sign. And I'm going to bring down that I times, let's do the same thing for 48. Well, 48 is what, 6 times 8? 6 is 3 times 2, and 8 is 4 times 2. But 4 is not prime, so we're going to keep going. So I got my 3, my 2. 4 is 2 times 2, and then don't forget that other 2. So now we have it down to the prime numbers. We're after the square root, so we're looking for 2 of a kind. So I have a group of 2's right there, so I'm going to take one out. I have another group of 2's, so I'm going to take another one out. And then I have this 3 right here that's by itself, so he goes back underneath the radical. So for this first part, I'm going to change colors here. I have I times 3 times the square root of 3, so this is just 3I square root of 3, plus, and then I have I times 2 times the square root of 3. Well, multiply those that are outside. I times 2 is 4I, and then we have our square root of 3. And now we can add these because they both have the square root of 3. But remember, when we add, we only add their coefficients. So I've got a 3I plus a 4I, which is 7I, and you keep the square root of 3. All right, on B, we cannot just distribute that square, okay? You can't distribute exponents if there's a plus or a minus sign in our problem, and this one has a minus sign. Remember, square then means that it's there twice. But I don't even worry about that yet because I see the square root of a negative, and I have to take care of that before I can do anything else. So I've got negative 2 minus, remember we're going to take the square root of that negative, which is our I, and keep our square root of 3 then. Now we know that that means it's there twice. So I'm going to write it there twice. And this looks like what we did in the previous example. Not A, but the one from before, okay? So now I'm just going to use my box now because I have 2 terms times 2 terms. Make it a little bigger box because I have that I square root of 3 on it. So I'm thinking I may need a little extra room to write that in. If I go outside my box, it is what it is, but I'm going to try to keep it in. So I have a negative 2 minus I square root of 3. Whoops, I forgot my negative on that one. Be careful. And then I have a negative 2 times negative I square root of 3. Then we're going to multiply. Negative 2 times negative 2. Changing colors here, trying to find one, is 4. Negative 2 times negative I square root of 3. Well, a negative times a negative is a positive. 2 times I is 2I, and then we have our square root of 3. On bottom left, I have negative I square root of 3 times negative 2. Negative times a negative is a positive. On the outside of the radical, we have I times 2, which is 2I, and then we just have our square root of 3. Now this last one, be careful. You got negative I square root of 3 times negative I square root of 3. So I'm going to do a negative times a negative is a positive. On the outside of the radical, we have I times I, which is I squared. And under the radical, we get square root of 3 times square root of 3, which is square root of 9. So when I take this out of the box, I've got 4. And then here I have like terms because they both have an I square root of 3. So remember, because they both have the square root of 3, we add what's on the outside. So we got 2I plus 2I, which is 4I square root of 3. And then I have plus I squared square root of 9. Now I can do some work on that last one. So I'm going to bring down my 4 plus 4I square root of 3 plus, now remember I squared is negative 1 times, what's the square root of 9? The 3. So we have 4 plus 4I square root of 3, and then we got plus a negative 1 times 3, and that's just going to be negative 3. Combine your like terms. 4 minus 3 is 1, and bring down your plus 4I square root of 3. This is written in standard form because the I term is last, and so there is our solution.